record this, and then I'm going to need the chat window. So yeah, then we are good to go. Okay, so hi everyone, welcome back after 2 weeks. Hopefully you got the things done last week, regardless of the missing lecture. But from now on, we're going to have this each week. So first week was mainly about introducing the whole concept of programming and about reading some basic input from user and producing some basic output. And then last week there were more conditional statements, the elif statement and the else statement. So we could come up with some kind of or more complicated conditional statements where exactly one block is executed based on what the user is doing or something like that. And then at the end of last week's lecture, we had a brief mention about the while loop, something like a simple loop that goes on until the user or until it's breaking out of at some point. That's what we're going to continue about today. Before that, a couple of practical things. There were some questions about using the external editor, whether it's possible already. And yes, it is. So if you want to use the Visual Studio Code editor to write your code instead of typing it in your browser, you can do it in the first 3 parts as well. Just follow the instructions at the beginning of part 4 about installing Python and installing Visual Studio Code, and you can use that to complete the first 3 parts as well if you want to, if you don't want to type in your code in the browser. And starting next week on the part 4, you're all going to need to use the editor, because then you can't type your answers directly into browser. You need to use the external editor. But as I said, there are detailed instructions on how to install the editor and install Python and so on. Another thing, whenever there's an instructor available in Discord, there should be a message stating that starting from this time until that time, I'll be supervising this or whatever. And during that time, if you want to, you can also send private messages to the instructor. Please don't send those messages in any other time, because our instructors are students as well. You can send me messages at any time, of course, but please don't send them to other instructors, because, as I said, they are students and they have other studies and other duties to attend to, and also hopefully some free time occasionally. And also, I hope that whenever you're asking questions, you ask them in the public area in Discord. But if for some reason you don't want to do it, if you want to use a private message to ask then it's possible during those specific times mentioned in the course material as well. But only during those times, and only the instructors who are said to be available during those times. Do you have any questions about the practical things, or about a couple of last weeks or something before we start today's topic? I think now is an excellent time. You can also ask later if you want to. Okay, so if you don't, then last time we started, as I mentioned, introducing a simple loop, and it was something like this. Let's see. So we have a while loop, a while statement, and we use true, the keyword true, as the condition over there. And then we could do something like to query the user for some values, for example. Let's do something like that. And then if the user enters -1, we can break out of the loop by using the break keyword. And then we can query for another value and do something with those values. For example, tell that sum of numbers is something like this, and so let's see what happens when we execute this one. It queries for a number and then another number, and then it displays the sum of numbers is whatever the sum of numbers is, like this. And if I provide -1 as the first input value, then the break statement breaks us out of the loop. So this was basically where we stopped at the end of last week. We can use a similar structure to do different kind of loop. We could do something like this as well. So what will the program output? What happens when I execute this program? Just describe it in, you don't need to write down all the values, but just like what's the basic idea? Yeah. So let's try it out, and we see that let's try it out now. So we get numbers from 1 to 9. Why 1 to 9? Why doesn't it output number 10? What is the reason? And this is actually sort of important. You were really close in your answers, but what is the reason that 10 isn't output? If you look at the code and look at each line and then try to figure out. Yeah, it doesn't loop back. So what happens here is that, let's say when the number is 9, it outputs 9 in here, and then it increases the value by 1. So the variable num becomes 10, and then 10 is equal to 10. So it breaks out before it has time to output value 10. So what about now? What does it output now? Yeah, it starts from 2 and it goes until, now it goes until 10. So it's from 2 to 10. So it's important to see what's the order of operations is inside these loops. So whether you're doing something with the value before you change the value, or whether you change the value first and then do something with the value after that one. So we see that if we change the order of these two lines, we either get values from 1 to 9 or from 2 to 10. And if we want to get values from 1 to 10, we can also always start from 0 or however we want to do. So this was what we were doing the last time. Basically, we had a while loop and we used true as the condition in while loop, meaning that the loop goes on until we use the break statement at some point to break out of the loop, and then the execution continues. Continues after the loop. So if I execute this one, it now displays the program continues here at the end of the loop. So this is basically the line that's executed after this whole block here, or the loop is done for. If we take a look at the more like general way to express the repetition, the loop, it looks something like this. So basically what we have is a conditional expression like we had in conditional statements, although it's a loop statement. And we always start by evaluating the conditional expression. If the expression is true, then we execute the block, and then we go back to evaluating the conditional expression. And this goes on until at some point the expression becomes false. If it becomes false, then the execution continues after the block. And the same can be achieved by using the break statement inside the block here. Okay, so what it means is that instead of using while true, we can actually use a statement or conditional statement in there. So let's try it out. Let's do something like while num is smaller than 10, let's output the num and then increase the value by 1. What do you think will happen here? What will happen when I execute the program in here? Yeah, it'll print numbers between 0 and 9. I think that's exactly what happens, and then it outputs done after that one. So we can have a condition in this while loop, and we always have a condition in there, but we can have a meaningful condition, like instead of using the break one. And what happens here is that we first, if we take a look at this one here, when we enter the loop, we check, Python checks the conditional expression. If it's true, then it executes the block, and then it goes back to checking the conditional expression. And this goes on until at some point the expression becomes false, and then the execution continues after the block. So basically, the initial value for variable num is 0, and 0 is more than 10. So this is true. And then it executes this one. It outputs the variable, increases the value by 1, and then it automatically rechecks the condition. And it keeps on running in that cycle until at some point this becomes false. So basically, when the value of variable num becomes 10, 10 isn't smaller than 10, 10 is equal to 10. So then the execution continues in here. Important thing to realize here is that the condition is always evaluated before the block is executed. So what will the program output now? What will the program output? Yeah, no numbers, only done. Let's try it out. And so it outputs done in here. And why is this? It's because it first checks the condition, and if the condition is false to begin with, then it doesn't execute the block at all. So exactly like shown here, it starts by evaluating the conditional expression. If it's false, then the block is never executed. In some programming languages, there's also something like a post conditional expression where the block is first executed and then the expression is evaluated, but Python doesn't have one. But C family languages, for example, C or C#, or C++ or Java or PHP or whatever, typically have also that kind of repetitional statement where you first execute the block and then you check the conditional expression. Python doesn't have one, and you don't really need one. You can do whatever you want with this one as well. Okay, so whenever we have a loop, there are 3 important components related to that loop, and those are the part where we initialize the loop, the condition part, and then updating the variables, usually the variables related to the condition. So if we take a look at this code in here, this is where we initialize the variable used in the condition, the num variable. Let's change it to 1. Here is the condition, states that as long as num is more than 10, the loop goes on. And then the modification part is here. This is where we modify the variable so that we go towards the terminating condition, so that at some point the loop will be executed no more. Now, if we make a mistake and remove one of these, what happens now? What happens if I try to execute, or if I execute, not try, if I execute the code now? yeah, it keeps printing 1. We can run it to see for ourselves. So there's an infinite number of ones. Well, not really infinite, but we talk about infinite loops, and infinite loops mean that loop that keeps on going until you terminate it by force, typically by clicking Control and C on your keyboard, or terminating the terminal like I did over there, or something like that. So, and the reason for why it did that was, of course, that if we don't have the modification path in here, then this condition never becomes false. If we don't change the variable of num, then it remains 1 as it was first initialized, and meaning that then it just keeps on printing the value 1, and then it rechecks it, but 1 is always smaller than 10, so it never terminates the loop. This is something you will encounter at some point, definitely. It's really typical to have sort of these infinite loops in your programs. Fortunately, they are easy to terminate, and then you can try to fix them so that it works. Most of the time, we want to end our loop at some point, whether it's based on something the user, like the values the user gives, or based on something we read from whatever source, or something, or whether it's about reaching some kind of result, whatever it is. But there are some programs where we want to have sort of like infinite loops. If you think about the program in your computer that's responsible for handling the mouse events, so that when you move your mouse or use your touchpad or something, that this mouse cursor here is moving, then that's probably a loop that keeps on going as long as your computer is running, so that the mouse is working all the time. So there are examples of programs that show that we don't want to terminate, but most of the time we want to have loops that will actually end at some point. Okay, so we talked about the break statement before last time, and the idea of break statement is that whenever you have a loop, having a break statement breaks out of that loop. So let's have one here. What will the program output now? One to 5 is it's close to 1 to 4 actually, because when the number reaches 5, then it's the loop breaks out before we get to output 5. But yeah, basic idea is the same. So what the break does, it breaks out of that loop immediately. So the loop execution is terminated, and then the execution continues with the first statement after the loop. Basically, in this case, this print done statement here. So that's what the break does. That's what we did last time, and that's what we can use break with any loop. And the typical way to use break is that when the loop has achieved whatever we were trying to achieve. If you're, for example, could be something like that, you're trying to find a first prime number, something between two numbers, and when you reach the prime number, then you don't need to check for any of the remaining numbers, and then you can break out of the loop. Or maybe you're searching for a name in a list of names, and when you find the name you're looking for, you can break out of the loop because you don't want to keep on searching, or something like that. So what we could do something similar. Let's say that we want to find, let's query a number from the user. And let's say that we want to find a number that's divisible by 23. And then we can break out of this one, and if it wasn't, then we just increase the number by 1. So now when we execute the program and the user enters any number like 124. Then it finds the next number. It finds the first number larger than 124, which is divisible by 23, and then we can break out of the loop because we don't need to find any more of those or whatever. But the basic idea of break is that it terminates the loop immediately. It doesn't end your whole program, it just terminates the current loop immediately, which can be useful in a lot of occasions when we know that we don't want to keep on executing the loop. There's another statement which isn't quite as useful, but it's sometimes useful, which is called continue. And the idea of continue is that it doesn't terminate the whole loop, but instead it goes back to evaluating the conditional expression again, meaning that it sort of like terminates the current round of the loop. So let's do something. Something like this, for example, doesn't make much sense, but still. So what will the program output? The loop starts from 1, then it increases the value. If the value is 5, it calls the continue statement, and then it outputs number. What is the effect of continue statement? Yeah, it will output numbers between 2 and 9, but will it output all numbers? Yeah, no 5. That's exactly what happens. So let's see if we execute this one. We get numbers between 2 and 10, actually. Yeah, it's because it increases it first and then outputs it. But it doesn't output 5. And the reason it doesn't output 5 is that in this condition here, we find out if the value is equal to 5, and if it is, then the continue brings us back over here, and then we just increase the value again, and this print statement isn't executed if the value is 5. So continue basically means that go back to evaluating the conditional expression again. Like this graph here shows, first evaluate the conditional expression, and if there's a continue, then we go back over there. So we execute the block until a continue expression is found, and if 1 is found, then we go back to checking the conditional expression again. Continue can be sort of troublesome. What happens here? What happens in the program in the current form? Yeah, it gets stuck when n equals 5. So what happens here is that the numbers more than 5 work perfectly fine. So it increases the value, it outputs 2. Then 2 is more than 10, it goes on. And then at some point when the value of variable num is 5, then it continues, and then it keeps on executing these 3 lines. So the program gets stuck over there. It never gets past value 5 because it never reaches this row again, this row 7 or line 7 here, because it keeps on executing these 3 lines over and over and over. So basically, if you're using continue, you need to be careful that you're not creating infinite loops like this with any input values. Break and continue can be useful, but you can also write any program without break and continue. So if you, let's have another example. Let's do something like this first. So So question, does it mean that continue basically ignores the value in the condition while re-evaluating? No, it doesn't ignore the value. It does re-evaluate the condition exactly like it did before. So it doesn't ignore the value. No, it goes back to re-evaluating. Let me show you another example. So let's increase the value first by 1, then let's state that if number is even, then we continue, and if it wasn't, then we output the number. So basically what we have here is a program that outputs all the even values between 1 and 10, 1 and 9, 1 and 10. So what happens here is that each time the value is an even value, instead of printing it, we go back here by using continue. So continue basically moves the execution back to this line 3 over here. So this one works. We can write a similar program by using something like this. So this produces the same exact output, outputting values between 1 and 9 as well. Whenever you're using continue, it's possible to write the same program without using the continue, and the same applies for breaking. If we have something like this, the program which outputs values until I forgot to output the number, sorry. So it outputs values between 1 and 4, and we can always change, for example, the condition in there or do something. So instead of using break, you can always use conditional state, or instead of using break or continue, you can always use conditional statements. And well, basically conditional statements to refactor your program. But sometimes break and continue can make your program more readable, maybe more easy to comprehend. And at least, even if you're never using them yourself, you need to know what they mean if you're reading code written by someone else. So that's why it's important to know how they work, even if you're not using them yourself. But as I said, you don't necessarily need to use them ever if you don't want to. You can always get around by using just conditional statements inside the loop. Okay, now if you take a look at this, again, back to this repetitional statement on this loop, we saw here that there's a block of code in here, and this block of code can contain any code, including other loops. So it's possible to write something called nested loops. Let's try it out. Okay, any ideas what will happen here? Okay, you don't need to type all the numbers written by program or outputting all the numbers the program outputs in the chat window, but anyway, what's like the basic idea? It's a bit more complex. There are two loops, and one of the loops is inside the other loop. So let's try it out and let's see what it outputs. And if you take a look at the values, you can see that they are 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3. So for each value of x, x gets values from 1 to 3, one at a time. And for each value of x, y gets values of from 1 to 3 again. So it's basically 3 times 3 iterations of the same loop. So it basically iterates or does 9 outputs. And what happens here is that we have this outer loop, which is executed 3 times. So we start from 1 and keep on going until x reaches 3, or x isn't smaller than or equal to 3. And then inside, we always start with the initial value of y being 1, and then we have another loop where we go on as long as y is smaller than or equal to 3, and then we output x and y, and then we increase y by 1. And after we have executed this inner loop, we then increase x by 1 and then continue execution in here. And this can be really useful, again, in a lot of occasions. A lot of occasions you want to do something x times y times, or maybe x times y times z times, or whatever variables you're using. But it's definitely useful, but it can also be sort of complicated. Now, if you're using Visual Studio Code, like you will be, at least next week, there are some visual cues here which can help you. For example, this line here, starting from the while statement, which displays the block starting from here, meaning that all these statements belong to the block started by this while statement here, and also all these statements belong to the block started by the second while statement in here. So that might make it a bit more readable, but you need to be really careful when you're writing nested loops, just to make sure that you are actually typing all the instructions where they are supposed to be. What happens here? So let's see, let's move that. So we had a program like this. Let's move this line of code. Let's indent it 1 step. So the program changes. What happens now is that if we execute it, we get 1, 1, 2, 2, 3, 3, and then we're done. And basically it means that both y and x are increased inside this inner loop here. Each round of this inner loop, and then it outputs the x and y. And then when we reach this conditional statement again, x is now equal to 3, so this is or equal to 4 actually, so this one is actually terminated. So if you want to run it 3 by 3 times, then it basically means that we need to be really careful on how to indent this line of code in here. You should also note that if you're using a break statement, it only applies to the current loop. So what happens here is we get 1, 1, 2, 1, and 3, 1. So this break terminates this loop after 1 round, but it doesn't affect the outer loop in here, this one. And the reason is that break is only affecting the current loop, not anything outside that loop. So also if we move the break statement in here, we get a different output stating 1, 1, 1, 2, and 1, 3 instead of 1, 1, 2, 1, and 3, 1. And so this outer loop is now terminated after the first round. And now when the outer loop is terminated, it of course terminates also the inner loop because it's inside the outer loop. So everything that's happening in this loop is terminated, including this inner loop in here. So if it sounds sort of complicated, that's because it can be sometimes. So you definitely are going to need these nested loops at some point in your programs. But sometimes, especially when these get longer, when you're writing more code inside these loops, and when you maybe have more levels than 2, it's possible that it gets a bit difficult to read or comprehend. So you need to be really careful on where you're writing your instructions. Or you get infinite loops, or you get loops that aren't doing what you're thinking they are doing, or loops that aren't actually loops that are only run or executed once, or something like that. But this is the basic idea. We can write loops inside other loops, and it's a really useful feature in a lot of occasions. Okay, we're going to move forward. Do you have any questions about the loops at some point, or do you want to see another example about something or something? Let me know. because we have another thing we're going to discuss today. It's about string operations. Okay, we can get back to loops at any point if you want to. Let's talk about strings a little bit. And we talked about strings, or you've been using strings for a couple of weeks for a lot of occasions, but we haven't really been manipulating strings yet. And by string, we mean a string is basically like a sequence of characters, the 0 or more characters. And what we've been using is basically things like asking user to type in his or her name or something similar to that. But let's see how we can manipulate the strings. And the basic idea of manipulating strings starts from the fact that all the characters in the string have index numbers. And in programming, whenever we are indexing something, whenever we are calculating, we almost always start from 0. And what it means is that if we have a string containing characters like this one, the first character of string is at index 0, and the final character of string is at the length of the string -1. So because there are 9 characters in this world exemplary, the first one, the capital E, is at index 0, and the final one, this Y, is at index 8. So there are characters between indices 0 and 8. Let's do something simple with this one first. Square with the user for a string, and then if it's an empty one, then we break out of the loop. We denote an empty string by just having two quotas without nothing between them. So that's basically how we tell Python that we are referring to string. This is still a string, but it just doesn't have any characters in it. So we're basically comparing the input given by user to an empty string to find out if it was an empty string. We can test it first. So if we give something else, if I give a space or something, that's not an empty string, but just clicking enter provides an empty string, and then the program is terminated. Then let's do something else. So output the first character of the string. And now we refer to characters by using these square brackets, and then we provide the index number of the character we are referring to. So now if you give any string except for empty one, like hi, the first character is H. For Python, the first character is P. For A, B, C, D, E, F, whatever, the first character is A. I give a couple of spaces, the first character is space for 1, 2, 3, 4, and so the first character is 1. So it's important to realize that Python doesn't really, I mean, it treats all characters equally. Space is a character, numbers are characters, letters are characters, all the punctuation is characters, whether it's a dot or exclamation point or parenthesis or whatever. So they are all characters. All have a length of one character. So let's include the final character as well. And we can get to final character by using the length of the string and then decreasing 1. And this is because if you take a look at this example here, if the length of the string is 9, then decreasing 1 gives us 8. So the final character of any string is at index length of that string -1. If there's at least one character in the string. If there are no characters, then there isn't the first or final character, so then it doesn't apply. But for any character or any string that contains at least one character, the final character is at that index. So let's try it out once more. Say hello. So we need to terminate it first and then Let's restart it. So first character is H, last character is O, or for Python it's P and N, or for 1, 2, 3, 4, or whatever is 1 and 8. So we basically can access individual characters from any string. Let's modify this a little bit more. We can use this information to access all characters in a string one at a time. So we can do something like this. Write a loop which goes on as long as the index is less than length of the string, starting from 0, and then output all the characters one at a time. And then we just remember to increase the index by 1. So now we have a program. We started. Have a program where we type in a string and it provides us all characters in that string one at a time. Like this. Or whatever. So what it means is that we can access all the characters in a string one at a time, starting from the first one or starting from the last one, or however we want to, which basically means that it gives us an easy way to extract information out of the string. You can do something like calculate the number of vowels in a string, or calculate the number of punctuation characters in a sentence easily, or whatever. And you can also manipulate those. You can create a new string based on the existing one by manipulating all the characters. So you can perform at least some simple cryptographic algorithms, for example, or things like that. There are examples about this in the material. Okay, then in addition to accessing individual characters, we can also, let's talk about this one as well. In Python, you can also use negative indices when you're accessing characters in a string, and the negative indices mean that we start from the end of the string instead. So -1 refers to the final character in a string, and then -2 is the second to final, and so on and so on. So we can use this one. Let's start from -1. And let's see that as long as index is larger than minus the length of the string, and then so we can now now access all the characters in a string in reverse order to do whatever we want. So we get all the characters, but we start from the final one and we go until the first one by just manipulating our loop a little bit. There are other ways on achieving this. This is something we're going to discuss more later, basically a little bit next week, and I think a week after that one. But the basic idea is still the same. We can access the characters by using their indices, and we can use the positive indices or the negative indices. And if we use the negative ones, then we start from the end. So the -1 refers to the final character in the string. Okay, in addition to accessing individual characters, we can also access slices, or basically substrings. And what we mean by substring or a slice is that it's like a part of the original string, starting from a given position and ending at another given position. And the syntax is that inside the square brackets, we type in the beginning index and then the end index, and then there's a colon between them. So if you want to get the first 5 characters out of a string, start from 0 and we go until 5. And now we don't need to have spaces in there, but I think it's easier to read, might be easier to read. An important thing to remember here is that the character at the begin index is included in the slice, but the character at the end index is not. So if we take a substring from 2 to 6, you get characters at indices 2, 3, 4, and 5. Sorry. So basically, the character at index 6 isn't included in the slice or in the substring, whatever you want to call it. So let's see what happens here. Let's have so for a string programming, always forgot to terminate this first. Let's do it again. Sorry. Programming, the first 5 characters are P, R, O, T, and R, or example, it's example, or for this one, it's 1, 2, 3, 4, 5. So you get the idea. So instead of picking out individual characters, you can actually extract, for example, words from a string. If you know the indices between which there is a whatever word you're looking for, you can extract it out of over there. Now, something sort of curious and also important to realize is that what happens is if I give a string for this program, if I provide a string that doesn't have 5 characters in it, something like hi, what will the program do? This is something you can just take a guess. If you haven't tried this, you can't know it, but you can take try to guess what it does. What could it do? It tries to take the first 5 characters out of a string containing only 2 characters. So what happens? Any ideas? Just guess something. Yeah, that's an excellent guess. Excellent guess as a first. It does only output high, and this can be sort of problematic. And why it's problematic? We could, if you take a look at this one, the basic idea is usually that if you want to know the length of the slice, or length of the substring between 2 and 6, for example, you can subtract the begin index from the end index. So the length of this one should be 6 minus 2, so it should be 4 characters long. And that doesn't apply for this one here, because we're trying to take a substring or slice with 5 characters starting from the beginning, but instead we get only 2 characters. And this might break your program if you don't check for it. It might break your program at some point if you're sort of assuming that you have a 5-character string, but you only have a string with 2 characters, then it might not work, or it probably doesn't work as intended. So this is something you just need to know, and you need to prepare for this one. This is even more strange. Let's change this a bit. So if you want to take the 5th character, and that's at index 4, am I right? Yeah. Start at 0, and the 5th character is at index 4. 0, 1, 2, 3, 4. So let's try it out, and let's see if I have a word like program that the 5th character is R, or 1, 2, 3, 4, 5, 6, 7, 8, 9. The 5th character is 5. What happens if I provide hi as an input string? What's the 5th character of string hi? Yeah, no value printed, and actually even more, it's an error. It states it's an index error, string index out of range, this is actually logical. We're trying to access an item at an index that's not present in the current string. We're trying to index or pick a character at index 4, but there is no index 4 at the string. And so it's a bit illogical that you're not able to pick a character from the string, but you can still take a slice or substring until that index, even if it's not present in the string. So it's just something you need to know. I think it's a bit illogical. I sort of hope that the slice operation would provide an error as well in this point, but it doesn't. So it's just something you need to know and prepare for it for yourself. Okay, other than that, slicing isn't that complicated. You provide a start index and the end index, and then that's basically it. There are some other useful string operations, but we are only going to talk about actually 2 more today, and then we're going to continue with new ones next week. The in operator is useful if you want to know it returns true if the substring can be found inside the string. So let's do something like the program which checks for if there was a string Python found in a string given by user. So if we execute this one and I type something like Python is fun, then it finds out there's a Python method over there. It's fun to code with Python, also gives us a Python mentioned. I call Python, this is fine. So it doesn't really matter where the substring is over there. I can actually do something like this and then just have Python over there and it finds it over there. But if I provide something that doesn't contain the word Python, then it displays the message that there's no Python over there. It's important to remember that this is case sensitive. So if I just type something like programming with Python is fun, it displays no Python here because it's looking for this all lowercase word Python inside a string. Because there's a capital P over there, then Python doesn't consider it as the same value in this case. So if you want to find that one as well, you need to do something different, but this is something I'm going to talk about later. Yeah. Sorry again. And then there's another useful method. If you're not only interested in whether you can find a substring, but about where you can find the substring, there's a method called find. So we can modify this one. Let's terminate this one again. So if you look for the find returns the index where it can be found. So if I type something like Python is fun, then it's found at index 0 because it's at the beginning of the string. If I type something like programming in Python is fun, then the index is 15. So it starts over there and so on and so on. So it basically gives you information on where the substring can be found in the string. So again, it can be useful, especially if you compare it with combine it with the slice operation, substring operation, and then you can extract things out of a sentence based on what you find in the sentence or whatever string you're working on. So this is something you get the hang of it when you try it a couple of times. So we're going to continue with more string operations next week, and the final thing I'm going to briefly mention today is something called own functions. And again, this is something we're going to discuss in detail next week. But we start again with something really simple this week to sort of give you a taste of it, and then next week we're going to discuss this in detail. So the idea of functions is that we can have code inside a function. Let's have a really simple function. And executing this code doesn't really seem to do anything. But when I call the function by using its name, like this, then it executes all the code inside the function block. I can do it several times if I want to. So if I call the function 4 times, then each time it executes all the code in here. I can add more code lines, of course, if I want to. And again, calling the function executes all the code lines in this function. And the functions can contain any code I want to. Do something like this. Like this, and now when I call the function, it executes the loop or the something extra over there, but when I call it now, it executes the code and outputs high 5 times like this. And we're going to talk about this in more detail next week, as I promised. But the basic idea of functions is that we can have operations that are needed often in our program, or we can have individual parts of our program separated into different parts of the code, and then we can call these functions when needed. So you don't never need to copy and paste the same code to do the same thing again. Instead, you can just have a function and then call it. And also something we're going to talk about more next week is you can have the functions can have parameters which change the behavior. So let's have output, and then let's have a message here. And now and message is a variable, it's a special kind of variable. So let's output message here. And now when I call the function, I can have the message displayed. So it's called output now. And now it displays any message I provide. If it's hello, it outputs hello. If hello all is the message, then it displays hello all 5 times. If it's nice to see you or whatever, then it displays that message 5 times in this function. So basically the idea is that we provide this parameter, and then the function uses the parameter as a variable inside the block. This is something, we have some really simple examples this week, but this is something we're going to talk about in a lot more detail next week, about parameters, about return values, about things like that. But I think that's pretty much it. We're also going to talk about this a bit more next week. Do you have any questions about the things mentioned today? So the mainly today and this week's material is about loops. There are a lot of things about loops, but there's a little bit about string manipulation, a little bit about functions. I can't remember if I provided the lecture slides are actually directly taken from the materials. If you take a look at these are screen captures from the material. So you basically have all of this and a lot more over there. If you prefer the slides, I can provide them to you if you want to. That's not a problem, but there's nothing in the slides that isn't mentioned directly in the material as well. So what I do is I just get some screen captures so that I remember to mention all the things in the materials, but there's nothing new in these slides in a sense. Any other questions? I think it's a good idea now. We can stop to